Lecture, I want to talk about orthographic projections. We've been working on single view drawings, which are fine for some situations, but in the real world, most things have 3 dimensions to them. So a single view drawing doesn't work anymore. So we're going to start working on multi-view drawings. So the process that we use is something called orthographic projection. And primarily what you're going to do is create multiple 2-dimensional drawings that when you put those together, it depicts accurately what the 3-dimensional object looks like. The reason we use orthographic projection is because most 3-dimensional objects are just too complicated to try to represent with one view. You can only show, if there's a height, a width, and a depth, you can only show 2 of those 3 dimensions. And it's a process that's been used for over 1,000 years. Some basic rules are what you're going to start with is a front view. So the front view is going to be the view that is the most descriptive of the part, and we'll talk a little bit more about that. And from there, so that'll be a 2-dimensional sketch. From there, we'll project off other views, which are typically a top view and then a right side view. You're always going to want to start with the front view, and that would be up to the person creating the drawing to decide. And you're going to look for some specific things. For example, show the most information about the part, show the fewest amount of hidden features. And also we typically look for the longest dimension because we use our paper so that the length is the longest. You rotate a piece of paper so the length is horizontal, so you typically have the front view with the longest dimension. So think about, if you see this picture here, a visualization of the person that's looking at directly at the front of the part, and that's what we're looking for. So as I said, we typically try to use a front top right side view. So think about holding the object in your hand, turning it so you look directly at that face, and we've decided that that's the face that's going to give us the most information about the part, and that's going to become your front view. And if you rotate the part, so now you're looking directly at the top, that's going to create your top view. And if you rotate the part this way, so you're looking directly at the right side, that becomes the right side view. So that's the technique that you want to use. One method that's been used for years to some success is this visualization technique, where you imagine taking the object that you're trying to draw. So here's my 3-dimensional part. I'm going to put it inside of a glass box, and then what I'll do is project whatever I see on this face. I'll project it out to this front surface of the box, and whatever I see on the top, I'll project up to the top surface of the box, and so forth. So here's the idea. I projected everything that I see here. Now it's only going to be perpendicular lines, so I project that line up there, and that shows me that edge. That line there gives me that edge, and so forth. That would generate your front view. Likewise, project those features up to get the top view, and project those objects to the side, the lines to the side to get your. Then you can imagine taking and unfolding that box. And what that does is generate those views. That's your front, your top, and the right side view. Now notice how the views are lined up, and that's critical for this technique to work. All these lines line up. So I know, for example, the height of the part is there. This is the same value. The length of the part here, it's the same value there. So once again, and when we draw on CAD, this is exactly what we're going to do. We're going to project some lines. And we're going to start our front view here. We're going to project these lines over, do our right side view, project these lines up, and we'll get our top view. To make this process work, we'll have to use some additional line types. Up to now, we've really just used object lines. So object lines are the thick, dark lines that represent the edges and corners of the object that you can see in the current view. Now, when we switch to multiple views, edges are going to be hidden sometimes. Those wouldn't be represented by object lines. If you have something that's hidden from view, then you're going to use a hidden line. So it's a dashed line. It's a simple dashed line with kind of evenly spaced lines and gaps. And that's going to represent features that you can't see in that current view. You'll see how that works. Center line is the third type of line. You'll see it's an interesting kind of line. It has a short line segment, a gap, a long line segment, a gap, a short line segment. So it's different than a hidden line. That's going to be used to represent the centers of round circles. So whenever you have a hole in a part, you're going to have a center line on it. Now occasionally you also use it for a line of symmetry for parts that we don't usually use that much anymore. So here's a kind of simple example. Now this isn't the greatest front view, but there is the front view of the part. So that's looking, for example, at this side of the object here. You don't really see much, but if you look inside, you see there's a little bit happening in there. There's a hole, and this is called a counterbore, where you have two different diameters of holes. One goes all the way through, and one has a depth to it. So there's my front view. Oh, there's also a hole on the side, right? So when I represent that, I'm going to see all these hidden lines. So those are features that are hidden from view. Those are the edges of those holes. And then you'll see a center line to represent the center of that hole, and a center line there to represent the center. For the center lines, think about if you're drilling the hole. That's the path that the tool would take. The drill would go to cut that hole. That's the path that the drill would take. Now when I go to look at the top view, so now I'm looking up here, I'm going to see these object lines that represent the outside, the object line that represents the outside of that circle there, and then there's one for that inner circle. I can't see those lines in the front view, so those become hidden. And you'll also notice in the top view, I'm going to have hidden lines for that hole. And I've got, now when you're looking down on a circle or on a hole, you're going to use, that's called a center mark. And basically it's two center lines that cross. So the center line would show you the center of the circle. A center mark would show you the center, but it's looking down from the top. Now for my right side view, which is over here, so now I'm looking, imagine standing over here looking at the part here. Notice the height is the same. All of these edges line up, these center lines line up. But now I'm going to see this hole because I'm looking directly at it. Whereas in this case, the hole, the only way I know it's a hole is because top and bottom hidden line and then the center line. So that really, when you see this object without the line, without the hiddens and centers, it would just look like a solid block. But when you add the hidden lines and center lines, it starts to help you to visualize what this object looks like. So if you put those three views together, you know exactly what the part looks like. How do you know which views to use? We try to live by the concept of a front view, a top view, and a right side view. Unless you have a reason to deviate, that's the standard that we use. Excuse me. The front view should be the main view. So if you only had one view to represent the part, that would be the view. It should show the most information, the fewest hidden lines, and also the longest dimension. And you typically put the longest dimension this way, lay it horizontally, because again, our paper is longer on the horizontal. And then you're going to project over and do your right side view. Again, notice how all these views line up. And I would project up to generate my top view. And I'm going to include the hidden lines and center lines as needed to represent the part. Think about looking at the object, so turn it in your hand, or if it was a giant part, you could walk in front of it and look directly at it. So see that arrow pointing there? That's what you're going to see in that front view. So your point of view then will determine what the view looks like on your drawing sheet. So there would be my front view that I see when I'm standing here. This is going to be my top view that I see if I was levitating, looking directly down at it. And that's the key. Remember, you're looking directly at these surfaces. So when you look directly at something, you'll see its true size and shape. And then the right side view would be looking at the part this way. So you can see how the geometry is represented differently depending on the different views. For example, this curvature here, that fillet, you can only see it in this front view. But that's the beauty of putting all the views together with an orthographic type drawing. And again, notice how the views are all lined up and how the use of object lines, hidden lines, and center lines. Here's kind of a little quick little thing that's representing, if here's my object, I'm going to first thing I'm going to do is start by sketching out the front view. And it's really, we'll kind of do almost the same thing in CAD. And then you're going to project up and leave some space between the views to do your top view. And then we can use something called a miter line. We'll talk about that a little bit later, where you can put a 45-degree angle line. And using that miter line, which you can do once you have a top view, is actually project features over and then down, over and down. So for example, this width between there and there will be represented here by projecting lines, so you don't have to remeasure everything. Now that works as long as everything is lined up and you leave an equal amount of space between all And here's another little example of the miter line. So it's going to be a 45-degree line that you can use as a construction tool. Now that 45, even if your front view isn't really have an upper right-hand corner, if you think about that upper right-hand corner, project up to 45, and that's going to give the ability to use that as a construction tool.